So, picture this. It's December 5th, 2023. A single change gets pushed out. A change designed to protect millions of websites from a really nasty new vulnerability. But instead of protecting them, it did the exact opposite. It didn't just fail, it set off a chain reaction that took a massive chunk of the internet offline. This is the story of how a security fix broke everything.
And when I say a massive chunk, I mean it. At the very peak of this incident, nearly a third, 28% of all the HTTP traffic flowing through Cloudflare was just failing. And Cloudflare is one of the biggest players on the internet. So for 25 very long minutes, websites, services, and apps that we all use every single day were just gone.
The fallout was so bad that Cloudflare came out with this incredibly blunt and, you got to imagine, painful admission. See, this wasn't some outside hack, it wasn't a piece of hardware catching fire. The problem came from the inside. It was a self-inflicted wound, and it raised some really serious questions about the systems that are supposed to keep the web safe in the first place. So how in the world does this happen, right? How does a patch deployed by some of the most brilliant engineers out there to stop a critical threat become the threat itself? Well, that is the exact mystery we are going to unravel right now. Okay, so to really get to the bottom of this, we're going to follow the breadcrumbs. First up, we need to talk about the tech at the heart of this whole mess, React. Then, we'll dig into the dangerous React 2 shell vulnerability that kicked this all off. We'll follow Cloudflare's frantic race to patch it, and then, this is the good part, we'll pinpoint the exact moment and the exact reason that the fix blew up. And finally, we'll take a step back and see what lessons we can learn from a disaster of this scale. So, before we can understand how it all went so wrong, we have to start with the technology that was being targeted. And that technology is React. You might not have heard of it, but it is, quite literally, one of the fundamental building blocks of the modern web you use every day. Look, if you've ever scrolled through Facebook or Instagram or binged a show on Netflix, you've used React. It's basically a toolkit that lets developers build those complex, dynamic websites. You know, the ones where things update in real time without you even hitting refresh. It's what makes the web feel less like a static page in a book and more like a fluid, living application on your screen. Now, React didn't just appear overnight. It actually started way back in 2011, inside Facebook, as a secret weapon to handle their crazy complex newsfeed. Once they open-sourced it in 2013, it just exploded. And over the next 10 years, it kept evolving, with huge updates that made it faster and changed how developers wrote code. Each step made React more and more powerful. But as we're about to find out, all that power came with some hidden risks. Okay, so one of React's secret weapons is this thing called the virtual DOM. Here's a way to think about it. Imagine the actual web page is a huge, fully built Lego model. If you want to change one little piece, you have to be really careful and it can be slow. What React does is it keeps a perfect blueprint of that Lego model in its memory. That's the virtual DOM. When a change needs to happen, it just updates the blueprint first, quickly figures out the absolute fastest way to change the real model, and then makes that one tiny change. That's why React apps feel so incredibly snappy.
And that brings us right to the bleeding edge of React, and, you guessed it, the source of our entire problem, React Server Components. This is a pretty new feature. The main idea is to have the server do some of the heavy lifting before it even sends the web page to your browser. This makes the page load way faster. But this brand new power also introduced a brand new and very dangerous kind of vulnerability.
All right, so now let's talk about the ticking time bomb that security researchers found inside these new React server components. It was a flaw so bad it earned its own scary nickname, React to Shell.
So every big software vulnerability gets an official tracking number, a CVE. This one was basically a flaw in how the server unpacked data that it received from a user's browser. Think of it like this. Imagine someone mails you a package. You think it's just a book, but there's a flaw in how you open the box that accidentally triggers a hidden device inside. That's pretty much what was happening here, but with code. This flaw allowed for something called remote code execution, or RCE. And you have to understand, for hackers, RCE is the holy grail. It is the absolute worst-case scenario. It doesn't just let them steal some data, it gives them the digital equivalent of a master key to the entire server. They can do anything they want. It is one of the most dangerous vulnerabilities that can possibly exist. And to really get just how bad this was, you can look at its official threat score. Security experts have the system, and each part tells a piece of the story. Attack vector network? That means an attacker can hit you from anywhere on the internet. Attack complexity low? That means it's easy to do. Privileges required, none. The hacker doesn't need a username or password. And user interaction, none. They don't even need to trick you into clicking a link. It was truly a perfect storm.
And when you add all that up, you get a perfect 10.0, the highest possible severity score you can get. This is not something you see every day. For the security world, finding React to Shell wasn't just a problem. It was a 5-alarm fire for the entire internet. Millions of websites were sitting there potentially vulnerable. So, with a 5-alarm fire raging across the web, you can bet the internet's protectors were racing to put it out. And Cloudflare, a company that sits in front of a huge slice of the internet, was right there on the front lines.
Cloudflare's #1 tool in this fight is their Web Application Firewall, or WAF. The easiest way to think of a WAF is like a super smart security guard that stands at the front door of a website. It inspects every single person, or, every packet of data, trying to get in, looks for anything suspicious, and blocks the bad guys before they can even cause trouble. And Cloudflare moved fast. Before React to Shell was even public knowledge, their team had already figured out how the attack worked and pushed new rules to their WAF to block it. And here's the crucial part. They turned this protection on automatically for all of their customers, free users, huge companies, everyone. So, on December 3rd, this looked like a massive success story. A critical threat had been stopped dead in its tracks.
So let's just recap. The protection was in place, it was working, everything seemed fine. But then, 2 days later, on December 5th, something went terribly, terribly wrong. The shield that was built to protect the internet suddenly became the weapon that broke it.
The failure was just breathtakingly fast. At 8:47 in the morning Universal Time, a new configuration change was deployed. Just 1 minute later, as that change hit Cloudflare's servers worldwide, error rates shot through the roof. By 8:50, alarms were blaring. Engineers scrambled, and just 21 minutes after that, they rolled the change back. By 9:12, everything was back to normal. A 25-minute outage that probably felt like an eternity.
So what on earth happened in that single minute? Well, it was a collision of two separate changes. The first one was actually part of the React to Shell defense. They were increasing the WAF's memory so it can inspect bigger requests. This was rolled out slowly, carefully, and safely, no problems there. But the second change? That was the trigger. To make room for the first change, engineers had to temporarily turn off an internal testing tool. Everyone thought it was a totally routine, harmless bit of maintenance.
The absolute core of the problem was how these two changes were deployed. The safe change, the buffer increase, used a slow and careful system designed for this kind of work. But the trigger, turning off that internal tool, used a completely different system. It was the break glass in case of emergency system designed for pure raw speed. It shot that change out to every single server in the world almost instantly. And that specific, seemingly harmless action, delivered at maximum velocity, it was the perfect recipe to trigger a bug that had been hiding in the code for years.
And you can see the impact right here in this chart from Cloudflare's own report. You see the line of normal traffic chugging along, and then at 08:48, bam, a vertical spike straight up. That is the exact moment a huge chunk of their network stopped serving websites and started spitting out critical errors. When the engineers started digging through the logs, this is the cryptic clue they found. An error from deep inside their WAF, attempt to index field execute a nil value. Now, to you and me, that's just gibberish, but for those engineers, that little phrase, a nil value, which basically means nothing, that was the key to the entire mystery. The code was expecting something, but it found nothing, and that contradiction crashed the entire system.
So let me translate that for you. Cloudflare has a kill switch to quickly disable WAF rules. They used it to turn off that internal tool. Here's the problem. This wasn't just a normal rule. It was a special kind of rule, whose only job was to kick off other rules. The kill switch had been used thousands of times, but it had never been used on this specific type of rule before. The code was written with a simple assumption. If a rule's job is to execute something, it will always have something to execute. When they flipped the kill switch, that assumption shattered. The code looked for its next instruction, found nothing, that nil value, and the entire process crashed, taking 28% of Cloudflare's traffic down with it.
So, with the internet back online and the mystery solved, the really hard work began. The post-mortem. What do you learn when the very systems built to protect you are the ones that break you? Well, this incident served up some very difficult but very important lessons.
Cloudflare publicly promised to make some huge changes. First, from now on, even a simple configuration change would be treated with the same caution as a major software update. Second, they're improving their emergency override tools. But third, and this is the really big one, They're shifting their entire philosophy to fail open. This means that if a security system like the WAF crashes, it should default to just letting traffic through instead of blocking it. That's a massive deal. It means the system is now designed to choose availability over perfect security. It's an admission that sometimes it's better to let potentially bad traffic through than to take a piece of the internet offline.
And the company didn't pull any punches about its own performance. This disaster happened just 2 weeks after another major outage. In their own report, they said that this pattern was simply unacceptable for a network as important as theirs, which really signals a deep commitment to fixing these underlying issues.
And all of this leaves us with a final, really tough question. This whole story is about the constant tug-of-war between security and stability. The push to patch a dangerous vulnerability led directly to a massive stability failure. Cloudflare's decision to fail open suggests that maybe, just maybe, stability should win. But what are the risks of that choice? As our digital world gets more and more complex, figuring out how to balance that clash is going to be one of the most important challenges we face.